Hi, Science 7. This is our video lesson on topic 3. You can follow along in your notes on page 20. All right, so we start looking at the atoms that are found in the 3 states of matter on page 20. And in solid objects, those particles are all packed together and they look like this. So looking below, when our questions are talking about having a fixed shape, solid objects are the ones that would be found in a fixed shape. When we go on to the question about held in fixed position, that also means the same thing. So that was also describing a solid. When we look at the liquid has particles that can take the shape of a container, like a glass of liquid like milk or water. They're relatively close together, but you can see they can move around a little bit. So you can tip your glass and those molecules will move. So liquid falls into this category, takes the shape of its container, and those molecules are relatively close together in a liquid, and they are also free to move around. For particles in gas, you can see that they are definitely the furthest apart. They will fill whatever container they are in. So you can have a closed container and know that inside there will be gas that fills that container. So gas can fit this category. And those molecules are far apart, furthest apart. So we can figure that that belongs in there as well. They are free to move around, just like liquids are. And they are, I think that was, take the shape of the container. This fits this category as well. So as we go on here in our notes, you can see that we are talking about how all the substances are made of these particles that we can't see. There are some spaces between them, and those particles are always moving, even though they are moving different amounts. Not so much in the solid, a little bit in the liquid, and very free to move around in the gas. But these 3 are the main points of the particle model. Moving on to the page that is next, page 22 in your notes. It does mention that temperature can affect the particles, and that's where we have a number 4 to add on to our particle theory, that if the particles start moving up, like when you start boiling water, then those particles will start increasing the temperature of that substance. So if you cool it down, temperature goes down, the particles will slow down. So we have temperature going up, then you know that the speed of the particles goes up. When the temperature goes down, the speed of the particles goes down. And the rule here is that temperature is pretty much the average speed of those particles. This part is not in your notes, but it's just a couple points on how the particle model is kind of hard to test because particles are so tiny. They're in large groups, and some are moving faster than others. So when we talk about temperature, we always talk about the average energy or average speed, because they are not all exactly the same at any one given time. Energy is bottom of page 22, measurement of the ability to do work, and the unit for energy will be the joule, and we will hear a lot about that in future science classes. The law of conservation of energy, energy cannot be created or destroyed, but we can transform it from one type to another type. And that is another very important rule of science. So we can have something like mechanical energy, where you hit a nail with a hammer, and that can get transferred into sound and heat, and so you can see that energy can be transformed. And you can have electrical energy, going into a toaster, creating heat energy. So those are transformations, but you can't just create energy from nothing. Okay, on page 23, if you're following in your notes, everybody, we have some statements, and you can stop this video right now if you'd like a moment to do these, but there are 3 that are true statements about energy. So if you'd like to stop the video, you can stop it, and you can start it up when we will find out which of the 3 are true statements. And they are the following. We cannot, just choose a different color here. We cannot create energy. That one is true. Energy can be transformed from one type to another type. So that one is true. And we'll just maybe make that a check mark. And the other true statement is energy does not take up any space. So if you had picked those, excellent job. And the other ones were false. When we think about movement of particles, we know that something hot has a much higher level energy than something that's cold. And so when it's hot, if this wasn't labeled, you would still pick this one, because as the particles are moving more, they are further spaced from each other. So we know this is the hot diagram. Thermal energy, the temperature of something is linked to how quickly the particles are moving. And the more energy it gains, the faster those particles will move. So the term thermal energy is the energy created or generated from those moving particles, and movement is the same as kinetic energy. So when we talk about movement, we're talking about the word kinetic energy. Okay. Heat definition is the transfer of that energy from one substance to the other. So heat is the substance that's always moving. If you touch some cold metal, the heat is going from your hand into the metal. Even though you feel cold, it's not the cold moving, it is the hot particles that are moving. They're the ones who are moving faster. And the image for this is just showing you how much more the particles are moving if they're high temperature, so they are the ones transferring their energy to the cold ones. Okay. Heat is the next part, bottom of page 23. We're still on page 23. And heat is always transferred from something hot to something cold. When it talks about the ice cube here, would a single ice cube have the same effect on a bathtub of hot water? It is talking about, first of all, the ice cube in lemonade, and basically, if you put the ice cube in there, it's going to melt because of the warmer lemonade. So then you're going to have a change in the average temperature of those particles if you had a thermometer in there. In the terms of the bathtub, because there are so many particles in the bathtub, the average energy probably may not even change if you just add one ice cube. But again, it is the warm water that is changing the temperature of that ice cube. Okay, so that was our little lesson today on topic 3, and you can check on your Google Classroom assignment page to find out what review pages you can do to review our topic, and any of the videos that you found in the topic 1 to 3 PowerPoints. Feel free to watch those to review any of these concepts. Take care, and we will talk to you